So the Fundamental Theorem of Calculus Part 2 is the part that we typically use in Calc 2. So what it does is it's going to take what we know about antiderivatives and use that to evaluate definite integrals. Okay, so here's how it works. If little f of x is continuous on this closed interval a to b, and capital F of x is the antiderivative of little f, then the integral from a to b of little f of x dx is equal to the antiderivative evaluated at b, where b is the top limit, minus the antiderivative evaluated at a, where a is the lower limit. So b is the upper limit, furthest to the right, and a is the lower limit. And then again, capital F is our antiderivative. So the way we do that, right, we find the antiderivative of your integrand. So remember, this part inside is called the integrand. Okay. We find the antiderivative of it, and then we evaluate it, the top limit minus the lower limit. Okay, and I'm going to show you some new notations for that as well. So antiderivatives, so right, antiderivative of 2x, add 1, divide by the new, so that'll be x squared. Right, the 2 comes down, it'll cancel that 2 out in front, and then plus x. Now, since it's a definite integral, I don't do the plus c because I'm actually going to find a number. If you have numbers for your limits, then your answer is a number. And then so after we do the antiderivative, we do this vertical line, and we'll say 1 and 4. Okay, so here's our capital F of x, and now we're evaluating at those two limits. So we do the top, so we plug the 4 into both x's. So I'm going to get 4 squared plus 4, and then minus, now it's two things, so I'm going to put some parentheses, so I'm careful, and then 1 squared plus 1. Okay, so what do we get? 16 plus 4 minus 2, that looks like 18. Cool, let's do the next one. So integrating from 0 to pi half, cosine x dx, so we first find the antiderivative. So the antiderivative of cosine is sine. So I get sine x, and I'm done with the antiderivative. So I don't write the integral symbol anymore. I did that part already. I found the antiderivative. And then it's between 0 and pi fourths, so we start at the top. So I need the sine of pi fourths minus the sine of 0. Sine of pi fourths is 1 over root 2. If anybody else is a non-rationalizer like me, minus sine of 0 is 0. So 1 over root 2, or write root 2 over 2 for my rationalizers. Okay, I think you guys have got it. If you want to pause and try this next one. So it's a nice antiderivative, so 0.1 x cubed over 3 plus 2x between 0 and 6. So plugging in the 6, so I've got 0.1 times 6 cubed over 3 plus 6 times 2, so that's a 12. 0, these are polynomials, so at 0, this is 0. So minus 0, I'll put that just so I'm sure. Oh my gosh, do I really want to do that? I don't really want to do that. I'll grab my calculator. So I have 6 to the third times 0.1 divided by 3 plus 12. 19.2, that sounds good to me. Okay, last one. So this one's a little bit tricky because I have that x in the denominator, right? And we don't have a strategy yet for integrating a quotient. So what's something we could do? Yeah, exactly. We're just going to split this apart. And then, so we're going to go still 1 to 9. And I'm going to write that as x squared over x to the 1/2 plus 1 over x to the 1/2 dx. And I've already gone to exponents instead of radical so that I can figure that out. Dividing like bases, we subtract. I still have not done my antiderivative, so I still need to be writing that integral symbol. 2 minus 1/2, that is 3/2. I'll go ahead and bring this guy up top too, so I'm ready. X to the negative 1/2 dx. I am making sure that I am, right, my limits, I'm continuous. So f has to be continuous, so I'm just making sure that I'm continuous between 1 and 9, right? And the only place I would be discontinuous is if I had a 0, because I'm dividing by that x. So if I had a 0 in there, that would be bad. But I don't, right? I stay on the right side of the y-axis, so we're good. Okay, power rule. I'm ready to do antiderivatives. So here's how I do it if I have a fractional exponent. So remember, I'm going to add 1, so that'll be plus 2 halves, so that'll be 5 halves. And then I divide by 5 halves, right? So here's how I do that very quickly. I divide by 5. Now the half comes down here, but remember, if the half's in the bottom of the bottom, it flips and multiplies. So divided by 5, the halves comes up top. Okay? So here, I'll do it on this next one too. X to the negative 1 half. So I add 1, so that'll be x to the positive 1 half divided by 1 half. The half comes up. And then between 1 and 9. Okay? Let's go ahead and plug in. So now I have 2/5 times 9 to the 5 halves, oh dear, plus 2 times 9 to the 1 half. So remember to plug it in both places, the top in both places, get that, and then minus the bottom in both places. So 1 to any power is 1, so I'll just do those numbers. So 2/5 plus 2. And notice I put parentheses around when I plugged in my 1 because, right, I have to subtract off both. I don't want to lose something there. Okay, so maybe you're thinking of these as exponents. Maybe you just grabbed your calculator, which is totally fine. But that'll be, right, the square root of 9 is 3. So I really have a 3 to the 5th plus 2 times 3. And then minus, what is that, 2.4, whatever that is. I'm going to my calculator because that's just what I'm going to do. So I've got 2/5, so 0.4 times 3 to the 5th plus 6 minus 2.4. So that looks like that one is going to be 100.8.